It said there were more women in the data set. 0.476 says there's more women.
Yeah, so what might be more interesting is the ratio of women cheating, not just the number.
So it looks like there were more women in the data set and less cheating women.
This is why you can't trust numbers, right? Let's do some data visualizations, huh? Am I right?
There you go.
Okay, so let's see. I think the first thing I tried to do here was I just did a scatter plot of their naughtinesses. So I took every feature in the data set, the little asterisk means it's running, and I did a scatter plot. And afterwards, I questioned why I did this. And actually, so this doesn't make sense. And this is kind of where, like, maybe you might think there's a correlation and there's not. Obviously, a scatter plot is not the correct plot type here because we have no idea what the quantity is on each of these dots over here. So you might actually think there's a correlation there. You might draw a line in your head, but that actually doesn't make any sense. We don't know how many numbers are there. So I just used the wrong plot type. So I switched to a bar chart after. And this is pretty these lines are actually kind of verbose. I could have written these a little bit more concisely, but this can be done very, very quickly. And I'm going to talk a little bit about how this differs from Excel. So anyway, these are the features. You can see sex here, age, years married, and these are unnormalized. So let's see. Any interesting correlations here? I was actually going to have people try to guess which ones they are, but that opportunity's come and gone. So years married, it looks like kind of that correlation. Well, here's interesting. Okay, so wow, huh? Yeah, look at that. More affairs apparently. I don't know. So that could be a result of it not being normalized. I don't know. But anyway, that's data visualization features. What?
Okay. So I also think there's a bias in the study of there are merely less 60-year-olds than 35-year-olds because old people die, go figure.
Yeah, no, I think
definitely a bunch of bias in the different ways.
I think probably there needs to be some normalization applied to these plots, which is kind of disappointing.
Yeah. But that's essentially a population distribution.
I like that sex is rated by 2/10. Alright. Yep.
Let's see. So yeah, you really can't derive a lot from these correlations. I think for this last part, all I did, if it works, I put there were basically different levels of naughtiness here. Because you had these, so that was if they ever had an affair, this is how naughty they were on the naughty scale. So basically, trying to see if there was any difference between people who were very naughty or whatever. So you could probably drive some correlations here. But anyway, this is how you would begin a data exploration. This was kind of done quickly, so you probably can't drive any actual relationships because the data wasn't normalized. But that's how you do it. If you just wanted to look at a bunch of features and start to drive correlations, or get an impression of where you might see something. So what we were just looking at was something like a 10-dimensional data set, right? We have all these different axes, and we want to see them all visually. So basically, the medium I used there was a bunch of bar charts. So that's one way to do it, and that's a place where Matplotlib is really powerful. So these are just some other things you can do. I forget what that plot's called. Pie chart. We got flow chart, or that's don't remember the name. 3D plots. All fun stuff. And I just came up with some points why you might want to use Matplotlib over Excel. Basically, some operations in Excel do take a lot longer, especially when you're mapping a smaller or a larger feature set to a smaller feature set. Things like that, where it's not just column operations on other column operations. So if you're noticing that you're doing that a lot, you might consider doing something like this because, especially if you know Python, it's not too bad at all. You can literally add arrays to other arrays, multiply entire arrays by things. The manipulations are easy, and plotting in Matplotlib, a lot of the calls, I didn't have any code examples that were short really, but the calls are literally just bar, right? So this is all kind of a one-liner complicated data manipulation, but in terms of plotting, it's just plot and these are subplots, right? So it's pretty simple and definitely worthwhile to kind of be able to do that quickly, to be able to pump those out quickly. Okay, so conveying information through data, using data for persuasion or to like show a concept or something. I wanted to talk about a library and kind of, well, some concepts behind this, some interesting examples first of all. So this is a geographic view of the US, I believe. This is electoral vote representation, and you can kind of see how things are represented better. There's like swing states in yellow and blue there. I don't know which one swings which way. They're on the edge, basically. And you can get a better impression of where the weight is held than the geographic map. So sometimes you can do interesting things where you're conveying information like that. And this is probably a good example of like an unbiased one, right? Because how do you add bias in that sense? It's just representing size. And yeah, so turning features into, this is like a technical term. Well, it's called encoding when you're converting data into some meaningful representation of it visually. And then I found this nifty little table online from Noah Elizinski or something. And basically what this is showing is different visual patterns that you can do and what they're good for. What this guy says is like really bad, that's used a lot, is people will use changes between colors to represent things, but color doesn't inherently have an order. So you gotta know when certain things have order and when that can be useful, because it can be really jarring and confusing if like a region is red and transitions to blue and it's representing anything other than temperature, right? Because sometimes we have correlations for color, sometimes we don't. So how many people have heard of D3? Nice. So D3, oh, wow. So many people. D3 is a really cool library. It's JavaScript data manipulation, or I would say it's a data-driven documents. It's a way of manipulating elements to create them out of data and do really interesting manipulations, and especially interactive things. So yeah, it's kind of like the jQuery for visualization. It's a really helpful library. And this is just kind of an example before I go into some stuff. This is an example of how you can manipulate things. What's interesting is you kind of like, you have this .data field, and you can put all your data in there, you can import that data, and then you can create elements automatically from it. So they have this really intuitive approach to creating like huge things of elements and things that interact. So the result is you have not a lot of code doing very, very complicated things. And if you hop on their website, they have a ton of examples. And with anything else, it would just take thousands of lines of code. It's really hard to imagine how to do it without using D3. So I have a couple of examples loaded in here. This is like clustering representation. Basically, you can click on these and see how they're organized, which is a really interesting thing of viewing, or an interesting way of viewing data. Sometimes data can be like an organizational structure, right? And I don't know if, at companies, do you guys ever have like, you know, that little menu where you can kind of browse up the hierarchy and you can see who your manager is? You guys ever look at those? You try to go all the way to the top to the CEO? There's definitely some bad ones, and it's interesting how people could do things better, and I'll talk a little bit about that too, where I think people can improve things generally. Other things like program architecture, right? There's a lot of things we can represent in here, like size can mean things and color, so there's a lot you can do to help better represent it than just text files, right? Just a huge thing of text files. This is the Guild website and a word cloud of it. I thought this was an interesting visualization they have on the site. So most common word, I believe, on the site is engineer, next to software, next to winning. Which I thought was pretty interesting. And then it's a pretty even distribution of words otherwise.
How many times are each of those used?
Engineer 11, software 8, and winning 8. Inventor is 7. Guild is 6. Hasbro is 4. Okay.
Was fondue one of them?
Fondue.
Is that one?
No, they're short.
Yeah, they're shortened on the bubble, so if I scroll over them, I get the full thing. It's Rensselaer.
What's the little purple one next to Guild?
Production.
What, maybe?
Parties. I'll send out the slides. You can browse it to your heart's delight. See all the words on our site. Well, it was at Harris. They had a huge command set that I was trying to organize it in my mind. So I used one of these visualizations and said, this one isn't collapsible, which is really disappointing. But I thought this was a good way of organizing all these categories of information in this kind of hierarchy. And all of this can be generated because D3, like as the name implies, it's data-driven. So it's you can easily change the data to adapt it to many different things, which is really cool. So a lot of these examples you can literally just plug and play. That's pretty exciting. People will think you're really cool when you can build a really awesome visualization just by copying example code. So this is another open question. So like, how do you best learn complex concepts? Kind of a segue, this is a different topic. How do you learn complex concepts? Like, how do you imagine like integration and stuff like that? Like, just shout out some things. This is already kind of implied. Maybe people think of like the Riemann sum, right? All the squares under for integration, or you think of like it being colored under. But the point is you have a like visual understanding of what these things are, and that probably conceptually helps you understand them a lot. Does anybody know convolution at all? Ever heard of that term? So convolution is this really cool concept that I really hated until I realized it was applicable. And they teach it in signals and systems. And basically what convolution is sliding one function over another function, taking the area under it, or multiplying the two functions by like the area under it. And I have a visualization to kind of show it in a second. This is really useful. A lot of computer vision algorithms are based off convolution nets, which are basically sliding convolution filters over an image that represent different functions, assigning them weights, and using that to identify things in the image. And that's used in some of these big computer vision competitions. That's what the people who win do. It's called a CompNet.
Yeah, I remember seeing, was it like before CompNets, like the top like accuracies were like in the like top 8 low was top 80s or something like percent, and then a team came through and was like, oh, let's try this technique, and they like won by like 9%.
Yeah.
It was kind of crazy.
Yeah, there's a lot you can do with it. It's also used in signal processing all the time. It's easily one of the most important things in signal processing. So the convolution, the convolution is the function. It is the black line. So there it is, being drawn. So those are two separate convolutions. Yeah, and it's weird to think, like, where would this even be helpful? And it's also, these are both like really simple functions. Once you start talking about discrete functions where it's not even a function, right, that's when it gets really hairy. So one library, I used this at a hackathon a while ago. I stumbled upon it, and I thought it was the coolest thing ever. Basically, this guy was just inspired to help people visualize mathematics a lot better, so he created this library that's really easy to use. And unfortunately, I don't have any samples of actual code usage of this, but it is really easy to use. So I'm going to scroll through a couple slides here. He goes over his motivations a little bit. Hopefully this isn't too slow. There's some cool ones that I want to show off. This project has evolved a lot, and now he's building, he's getting more and more low level. And oh yeah, here's one of the ones I wanted to show off. This is for sinusoidal functions, among other things. And a lot of these, I don't think this one's not interactive, but a lot of these you can actually scroll around. So you can definitely see where this could be viable in education and other things for just helping people visualize these complex concepts. There's one other one in here that's pretty good. Let's see, I don't know if it's this one. How he does this is really interesting too, because all of these, and I'll explain this in a second, but basically all these are defined as regular JavaScript functions, and then he kind of interpolates between them to draw the graphics, which means it's really easy. You just define whatever like complex function you want to show as a function of x, y, z. It figures out the rest. It's pretty crazy. And also these animations are all built into the library, as well as a bunch of interactive features. It might be later, and I might just skip to.
So what we're looking at here is the library view.
Yeah. Yeah, so this is the library, and this is an example. So this I really like because I didn't understand how these curves were done. If you've ever used Photoshop, there's this spline tool, right? I believe this is one of the options for doing the spline. This is a Bezier curve. Bezier. And this is how it's done. So this is a quadratic curve. I mean, this isn't actually how it's done. This is a way to visualize how it's done. So I thought that was pretty helpful for seeing how these curves are made. So how hard would that have been to convey in words, you know? Probably pretty difficult. I mean, to an engineer, maybe not so much, but it is. So these are pretty interesting. I would definitely look up MathBox if you just like visualizing some things that maybe you had trouble with in the past. So. Basically, for coding MathBox, you define your scene, which is very short, like something like 10 lines, and you just set it up, kind of say what you want to display in some kind of defaults. You then create a script, so you're stepping through a script. You want to show the manipulation of various math functions, and then you define your functions. So that's like, you define it literally like a mathematical function, and it figures out what's in between, which is one of the strong points of the library. Okay. The next thing I want to talk about, what's this thing called? Anybody know what this is? What does this represent? Word cloud. What is it representing? In the English language, exactly. So while I was at TripAdvisor, we were working on a hackathon project, and the problem we were trying to approach was basically you're browsing for restaurants. So I'm gonna pose a problem, and I'd like to hear how somebody solves it. So I'm in Boston, and it's 3 a.m., and I want something to eat. I like a very specific set of foods, and there's no places by me, or I'm sick of places by me, so I want something along the red line, because I can go anywhere along the red line. So how do I find the place to eat? What's your solution? Grubhub.
Or Yelp.
Yeah, Grubhub or Yelp. So I can view a list of everything that's available. I can even sort by distance. It won't give me everything along the red line, but it'll give me everything in a radial distance. So if I'm comfortable eating with local places, or I have time to browse, it's a really good way to do it. I might even be able to sort on my food preferences. So there is a solution to this problem. What I was proposing at TripAdvisor is that we have a new solution to this problem. And that's that we display basically word clouds overlaid on a geographic map. So I actually posted this over the summer. I don't know if anybody saw it. I posted like a screenshot, but maybe it didn't make a lot of sense. So the idea behind this was you would be able to browse a map, and you would see you would see things that might stick out to you. Like you would browse it, and I'm going to show this in a second, so it'll be easier to show. But you'll see things like, I don't know, Indian food. And that'll stick out to you. You'll recognize that, and then you'll know how good it is by the size of its characters and things like that. So basically combining spatial things which are really good on that table. Spatial is at the top. It's a really good way of representing data, right? That's why plots, are really great for us to see. So that's basically the concept. There was a kind of an interesting problem that I had to solve doing this. And I only got like a heuristic solution, so it's not really worthwhile. But you have words, and you want to put them in a certain location. You want to minimize the distance to that word to where it's actually spatially located. So you have an Indian place, and it's being pushed by a place with a bigger word that's really good. Like it would be better than an Indian place. A Chinese place, I guess. I don't know if this is offensive. So that's big. It's being pushed out of the way. You want to minimize the distance to its location so that you're giving the user an accurate, an accurate coordinate for that place. while still providing all that size information. So this is a 2D bit packing algorithm with emphasis on spatial things, which I could not find at the time.
Why doesn't it choose size versus saturation?
Size versus saturation. Did you clarify what do you mean by saturation?
So if something's very low quality, I will have like an alpha 0.2 of the.
Oh, so use transparency as another thing. Yeah, that's a possible option, but the thing was we didn't want to overlay any words. But yeah, we actually, the original actually did have transparency. We opted for this after looking at it for a little while. This is the visualization. I'm not the designer, but I did all the word packing. So I'm going to try to run this and see if it works. I'm showing this library in the hopes that maybe somebody uses it for something because that's pretty cool. Yeah, let's run that guy. Cool, explore your taste. I hope I can show this. This is still using TripAdvisor's data. So I can see like all these things. I might see some things that stick out to us. One thing they were really concerned with is that it was too busy and that things might not stick out to you. But all that is configurable. These things on the side are filters. I don't think they're that important. As you zoom in, you get closer to more specific things. So great wine selections. These were actually one of the members of my team was like the NLP guy. So he did a bunch of sentiment analysis to figure out like what the best dishes were at places. So white wine, worst restaurant experience. there were actually a lot of bad words that were pulled in, but like overall it worked pretty well. So now if I know where I am on the map, I can kind of explore along a certain line and look for things that stand out to me. And one thing we didn't add to it was what time the place is open, which is definitely the most important thing to me. So never got to that, but definitely an important feature. Okay. So in summary, nearing the end of the talk, my 3 slides. Why do we like data visualization? The 3 major points that I'm proposing right here are it helps us explore data and find relationships if you normalize your data. It helps you convey information, whether that's for persuasion or just to explain some kind of concept. Complex concepts can be learned, and we can also offer compelling experiences, especially with user interfaces. There's a lot of places where we have tons of data, but we're not showing all that data. We might just be offering the best recommendation, but maybe we can show them a little bit more. And I'll take questions.
Name off your 3 favorite discrete examples of data visualization. What would they describe in order?
That's interesting. 3 discrete examples of data visualization. I don't know if I could name off 3, so I don't know if I'll get a satisfactory answer to that question, but I do, my favorite visualizations are not, like, it's got to communicate something and also like let you find patterns. It's like a puzzle, right? You want to be able to solve the puzzle in a way. So like if you're looking at a social network graph, like sometimes those are cool to have all these spirals and weights and shading, and you're like, oh wow, that's kind of cool. I can like see all my connections. Like Wolfram Alpha will give you a bunch of visualizations as well as your data, I believe. If you type it in and then you just give them all your data. A good visualization, you know, maybe has that mix of exploration. For me, exploration and that. So social network graphs especially bother me because a lot of times they convey nothing at all.
Well, like I said, not necessarily the type of graph. Like, is there any time you just looked at visualization and said, wow, that really just displayed incredibly well?
It's interesting. I can't think of any discrete examples off the top of my head. It's usually, if I did, it would probably be part of an infographic because there are actually designers behind like a lot of great data visualizations. But like the times that I get excited over are when like I'm exploring or it's solving something, right? So in data mining, we do handwritten digit identification. That's one of the challenges, which is also a Kaggle challenge. It's really exciting when you're like, wait a second, can you draw a line there? Like, could you actually split that information? So that's kind of interesting. That's a fun thing. And originally, I was going to talk a little bit more about IPython and Matplotlib, and how you can like really manipulate things to see kind of cool things in there. But that's why poor man's data visualization, what you do cheaply and effectively to exploit data. Anyway, so. Kiana, question? No.
I was suggesting for a video to watch one of them, but
Oh, okay. Yeah, actually, does anybody have any like cool data visualizations that they like? I was gonna ask that.
This one guy who made this thing for TripAdvisor with all these words.
I actually went to a lecture by a guy who like a professor specializes in data visualization. One of the things he showed was it was just kind of neat. It was a plot of like top representative like music songs for the various like music genres and how the music genres evolved from each other, starting from like 1600s up until present for at least like Western music. And it was really cool because they had like the different sections, and they were basically lines that would show the like families, and then if a new family started, it would give you that section, and you could actually like press the music in there and sort of like hear it as it changed over time.
Oh man, that's got a whole nother dimension.
Yeah,
If
it
you
was,
can find that, you should please share.
Yeah, that sounds pretty
it
cool.
was really cool. Yeah, that was probably one of the more interesting ones as well, because it wasn't just this, right? It wasn't just visualization; it also had like the actual audio component as well.
Yeah, that's a dimension. I haven't even thought of that as a dimension, right?
Yeah.
That's really interesting because we pick up patterns in sound too, but I've never heard that used as a medium for data exploration.
Yeah.
But it definitely could be. It's like people who listen to radio sounds in space. They listen to it audibly. Sometimes.
I guess I read a fun book one time that was talking about different maps and why they were drawn the way they were. I did the classic example of like a map that's done very, very well for specific purposes, like I think in New York State, something like that.
Yeah.
I think this product is a very classic case.
Yep.
But it was also pretty cool because they went through and they explained like, I think undersea cables is a good example of that too, right? It's like, in reality, mapping where an undersea cable is a painful and very awful process. But trying to convey like understanding of where different parts of the world are connected by internet to other places is also like a fun thing. It's far more applicable. So it's more of like what concessions do you make as far as getting less accurate from the geographic location of the cable, but being more accurate for being able to display information of what's connected to what via the internet. So it's kind of fun. But there's just a whole book of just different maps, like discussing why the person decided to do this, why they decided to like these weren't important, but these were important. So it's fun.
It is cool. Yeah, and the subway is a great idea. I'd love to see like more automated geographic solutions to those kind of problems, or automated solutions to maps like that.
What are your thoughts on all of this like VR data visualization stuff?
I actually don't know anything about VR data visualization, but educate me. What's going on?
Well, basically it's just that I've noticed for like every single one of these companies that is like doing the VR headsets are all have these like grants for using these for data visualization purposes. Like that's just a thing that I've seen. Was Oculus did. I saw one for the HoloLens. I've seen one for the Unreal Engine team. So I was just wondering if you had seen any of that stuff.
That's interesting. No, I haven't seen any of that. Most of the data visualization I've seen has been in the context, at least for exploration. Like I can't say anything about like data visualization for like the coolness of the effect, because most of the stuff is like I like is the exploration. Most of it I saw when I took a course, data mining for knowledge discovery, and that guy he basically, whenever he wanted, he would pull up a visualization of the data set that he was looking on for a specific feature, and he would manipulate it very quickly. And that's what I got the impression that you have to be really quick on these tools to know the data set you're working on. Like it's not like data sets usually aren't obvious. You can have up to 1,000 features. You need to be able to analyze those quickly. So yeah, I can't say too much on.
What do you think your thoughts would be? Because the idea with the standard is never just gone on the screen in front of them. The idea that they have is somehow that adding this other spatial component of rotation and position would help. I'm not convinced.
I'm trying to think how it would help. yeah, I can't say off the top of my head. Yeah, I don't know.
Okay, I just thought it was interesting, because like, there's like these, like the HoloLens specifically, or like the Project Tango, or all those other ones that have like the positional data as well, so that you could physically move yourself to see other pieces of the data as well. Like, it sounds like it might be useful, but I'm not sure.
Yeah, I mean, and to an extent, we see like when you're looking at like these 3D plots, the 3D plots I was showing earlier, you're still looking at like a 2D projection, you know?
Yes.
So as close as we can get to like kind of letting somebody see something in 3D,
Yeah.
that could really help. But it's hard to say. Maybe they have some creative ideas. I don't know. Send me a white paper. I'll read the summary and then take the data. Jim.
Yeah. This is gonna make us millionaires here.
Okay. Both of us or
All of us.
all of us? Okay.
You're gonna take your data, right, and you plug it into a VR roller coaster, and then you can ride it in. So like you got the line graph of the inflation in the United States over the past few years, and then you know you're about to be on the ride of your life.
Yeah, I think that'd be pretty fun. Like you could be, you know, like for like the children, you would have like just like a sine kind of curve, some light slope. But then like you'd be doing the stock market for like for the older kids, for the adults.
Who's it?
So I might have missed this at the beginning, but this is for poor men, right?
Right.
So what does a rich man do?
So a rich man uses this company whose name I was struggling with earlier. They'll use tools like this. They're sophisticated software suites for data visualization. So if you're in a company, and I only know this because I know people who have worked in these kind of roles, if you are doing data analysis for a company, what you might do is literally spend all day developing models. Like say you're working for Verizon. Your job is to develop a model for determining when somebody is going to leave so that Verizon can send them a discount. So for that, they have very sophisticated tools. There's probably not much programming involved, and they can really parse through that data quickly. So there are very expensive tools used by companies like these. And there's also a market for buying data, which is pretty interesting. A pretty big market that we just don't really hear about. It's all part of this.
What's the largest data set you can work with?
TripAdvisors.
Like, what was it? Just like,
I worked a lot with TripAdvisor's data set. Unfortunately, I didn't do a lot of data visualization. I did a lot of ad hoc data analysis to figure out things like our features, our like new features that are coming out deterring users from clicking on this or that. So that was looking at all of the sites. I guess in terms of that was looking at like how every single user who like clicked this button for a day or came from this web page, people who were exposed to this, did they sign up after, stuff like that. So that is massive. And in fact, they for their Hadoop cluster, which I'm assuming is pretty efficient, it would take queries like up to 15 minutes. It was crazy. These are SQL queries. There was also this service we use called Amazon Redshift, which I guess is a lot more expensive, but it was also significantly faster. So Amazon's got some crazy technologies that they're pumping out to do this stuff really quick. The NLP data set we worked with was the most I've ever analyzed. So while I was working with the people on my team who were doing NLP, we were literally going through every review that had ever been done in Boston or had been done in that year, which is a lot of text. We basically touched all of it for that year in Boston, which took a long time, but it was fun. It was a good time. We won, by the way. I don't know if I said that. Okay, anything else?
For getting the Python notebook up and running, I saw it was running on a web page.
Yes.
Is that something you can put on a server? And
Yeah, definitely. You can put it up on a DigitalOcean instance, have it running all the time.
Excellent.
Yeah. One of the things I want to see, and I think they're actually working on, is collaborative iPad notebooks. So maybe like 2 people could be doing analysis at once. I think that's a whole nother talk, collaborative development and stuff like that. But yeah, that'd be really cool stuff. Cool. I guess I got some time, so I'll go right into the PCB workshop. Is that no?
Actually, you are right on the money. It is 11 o'clock.
Nice. Okay. Thanks, everybody.
Thank you.